Hello everyone, my name is Pravina Rajasekharan. My metric number is F24A0970. Today, I like to present our study title, Solar and Hybrid Drying System, Green Innovation for Reducing Energy Conservation from Group 2. Our research focus on the growing energy crisis and how it affects food and non-food processing, especially in the agro industry. We explore solar and hybrid drying system as a green technologies that offer sustainable, cost-effective and eco-friendly alternative to traditional drying method that usually on fossil fuels. Let's see the introduction part about solar and hybrid drying system. Drying is one of the most important operation in the agro product processing. It's help remove moisture from food products like grains, fruits, vegetables, spices and fish. This prevents microbial growth such as bacteria, yeast and molds, and it extending the shelf life of the product. Second, traditionally, drying uses a lot of fossil fuels which contributes to pollution and high cost. So, we need a cleaner, cheaper alternative. So solar energy is a perfect option. Now, types of drying system. There are three types of solar dryer. Firstly, direct solar dryer, DSD. Secondly, indirect solar dryer, ISD. Thirdly, hybrid solar dryer, HSD. Firstly, direct solar dryer, where sunlight shining directly into the product. Second, indirect solar dryer, where air is heated using solar panels and then pass over the food. Third, hybrid solar dryer. It combines solar with other sources like electricity or biomass to make it more effective during cloudy weather. So these are the three examples picture for the three types of the solar dryer. For this part, recently technological advancements have significantly improved those systems. For an example, hybrid solar dryer equipped with additional heating sources and terminal energy storage can maintain stable drying temperatures. Some modules include solar assistant heat pumps which enhance energy efficiency and product quality. Surface modification and heat retention techniques are also applied to minimize energy loss. Such enhancements help maintain nutritional value and visual apply in dry products, making them superior to conventional open sun drying. These are the case study that contributed by ANAS at 2024 by tested three types of solar dryers on mushroom slice. These studies found that thinner slice and pre-treatmented reduced drying time by 1483 and 26.66 minutes respectively. HSD solar recorded the highest terminal effective at 77.45%, proving that hybrid dryers are the most effective in the term of performance and energy saving. Next will be the impact of green technologies. From an environmental perspective, solar and hybrid dryer significantly reduce fossil fuels and greenhouse gas emission. Those systems utilize renewable energy sources such as solar radiation and agricultural waste such as coffee husk and wood, supporting circular economically principles. In cocoa drying, for instance, hybrid dryer have been shown to conserve over 56% of energy, contribute to carbon emissions reduction. Second will be the economical perspective. Solar and hybrid dryer offer long-term savings, especially for small and medium-scale agro processor. Although the investment may be high, operational costs are considered lower due to reduced electricity or fuels usage. Furthermore, those dryers can be built using local available materials, fostering local capacity and economical independence. They also improve product quality and reduce spoilage, allowing producer to earn higher profit and access bigger markets. Third will be from an industrial perspective. Those drying technologies align with corporate environmental responsibility and sustainability certification goals. Increasing companies and government are investing in pilot programs to promote the use of renewable energy and post-adventure processing. This effort not only strengthened industrial output but also driven innovation in drying technologies, energy storage, and automation. As the agro industry moved toward cleaner production, solar and hybrid systems are becoming central and sustainable development trends. Now, let's look at some of the key challenges that limit the adoption of solar and hybrid drying system, especially in rural agro processing. First, lack of awareness and education. Many small-scale farmers and processors still lack awareness of solar and hybrid drying system. They may not fully understand the benefit of how to operate those systems effectively. Second, high intentional cost. Although those systems are cost effective in the long term, the intentional setup cost for solar panels, collectors, and backup systems is too high for many small and medium-scale producers. Third, maintenance and technical expertise. Those systems require regular maintenance, cleaning panels, checking airfalls, repairing leakings, and this needs technical skills many rural users might not have. Fourth will be weather dependency. Solar system heavily rely on sunlight, so their performance is affected during rainy and cloudy weather. This is especially a problem during the monsoon season in tropical countries. Fifth will be moisture control and product standards. Achieve consistent moisture levels in difficult, especially in base solar dryers. Poor moisture control can result in uneven drying, spoilage, or failure to meet market quality standards. Last will be limited energy storage and scalability. Solar dryers does not work well at night or on lower light days unless there is energy storage, but many systems do not have reliable thermal storage due to cost. It's also challenging to scale up those systems for large commercial use or integrate them into existing food processing lines without major designers. So, while solar and hybrid dryers offer many benefits, there is challenges, especially cost training and weather dependency need to address to support wider and longer term adoption of green drying technologies. After identifying the challenges, it's also important to focus on the solution, and thankfully, there are many promising approaches to support the wider adoption of solar and hybrid drying system. First, financial incentive and government support. One of the best ways to reduce the burden of high intentional costs is toward government subsidy, low interest loan, and tax incentives for farmers or producers who adopt green technologies. Second, technical training and capacity buildings. Proving vocational training for local communities can help develop the skill needed to install, maintain, and repair those systems. This reduces dependence on outside technicians. Third will be development of hybrid system with backup energy. Hybrid drying that combines solar with electricity, biomass, or LPG help maintain drying performance even when sunlight is not available. Technology upgrades for energy storage and quality control. Improving thermal energy storage systems that using materials that store heat longer can help operate dryers at night or on cloudy days. At the same time, integrate temperature and moisture sensors ensure better product quality. The last will be policies to encourage standardization and market access. Government and organization can also help by setting quality standards for solar dried products. This improves consumer trust and market access, especially for export. In short, with the right combination of financial support, training, and technical innovation, solar and hybrid drying system can become a powerful solution for sustainable agro-processing, not just only rural areas, but even larger scale operations. Last but not least, as a conclusion part, solar and hybrid dryers are powerful tools of green technologies in food and non-food processing. They save energy, reduce environmental damage, and support small farmers. Despite some challenges, with the right training and policies, those systems can be visually adopted and make a real difference. Thank you for your attention. Hope you all enjoy the presentation slide.